All right, college algebra, we're doing chapter 3 test review. Skip over the problems you don't need help with and focus on the ones you do need help with, okay? I'm going to do every problem. Starting with number 1 here, we've got this equation. Okay, what are we going to have out of this? What's this parabola going to do? So, first of all, I'm going to look at right here, since it's a plus 7, that means my vertex is going to have negative 7. And then there's my y value. Negative 7, 6 is my vertex. All right, so let's see here. Negative 7, 6 could be this one. Nope, nope, nope. Could be this one. Nope, nope, nope. So it's one of these two. Now all I need to do is determine, does this thing open up or does it open down? Well, look in the front here. There's a negative in front of my x squared, which means it's going to be concave down. So, E. All right, and we see the answer right there was E. That's right. Okay, go on the next one here. All right, we got us a function here. All right, what's the domain? Well, this is quadratic, so every time negative infinity to positive infinity for domain when it's quadratic, on the quadratic one, every time. The range is what changes. So if you look over here, the range is up and down. The lowest it goes is negative 4, and we include that for the bracket. The highest it goes up forever to infinity. So there's my range. Okay. The vertex, we just did that a minute ago in the other problem. Negative 4 right there be my x. Negative 4 be my y. So negative 4, negative 4. There's my vertex. Okay. The equation of the axis symmetry right there, this number right here. Now look here, it's got the x equals on there, so you just need the negative 4. But this x value of the vertex is always the axis of symmetry. All right, the y-intercepts. All right, y-intercept is when x equals 0. X-intercept, guess what? That's when y equals 0. Okay, you need to remember this. So the y-intercept, I just put 0 in for x right there. So 0 plus 4 be 4. 4 squared 16 minus 4 be 12. You just use your calculator. But when I put 0 in for x, I get 12 for y. That's my y-intercept. Now find the x-intercepts. That's when I let this be 0 here, and I saw that. But I think from the picture, I can pretty much tell this is going to be 2, or negative 2 and negative 6. So negative 2, 0, negative 6, 0. That'd be my x-intercepts. And here's the answers down here. I think I got everything right. All right, go to the next one. Number 3. Okay. All right, this one we got to graph it. So here you go. Here's, this is vertex form, so negative 1 is my x. But see, there's no number right here, so that means 0 is my y. So there's my vertex right there. All right, so if I graph this, negative 1, 0, right here's my vertex. And if you notice, there's no number in front of x squared, and there's no negative, which means it's not concave down. So this is concave up, and so when I go over 1, 1 squared is 1, it goes up 1. When I go back 1, negative 1 squared is 1. And so here's how my parabola would look. Now if this thing had a number in front, like a 2, that means when I go over 1, 1 squared would be 1, times 2 would go up 2. All right. Now my axis symmetry right there, that number always. Now look here, there's no x equals on this one, so you have to type it in. So don't forget, you got to type, well, I tell you what, type in the x equals on this. You didn't have to on the first one because it was already there. Domain, guess what, man? Negative infinity, positive infinity every time on quadratic. Quadratic's always negative infinity, positive infinity. Now my range up and down, the lowest down it goes is right here, 0 for y. We're going to include it, and it goes up to infinity. See, this thing goes up forever. Now, getting down here to the largest open interval in which the function is increasing. Increasing as you go over left to right, it goes up. Okay, which is a occurring right here on this. See, as you go from left to right here, from left to right, this thing's going up. So it starts right here at -1 and it goes to infinity. So this is going to be -1 to infinity. And there's no brackets on it, increasing and decreasing. Now the large slope interval on which the function is decreasing. Decreasing means as you go from left to right, it's going down. That happens right here on this side. And see, it goes up forever here, which means it goes to the left forever. So this thing goes from -infinity all the way to -1. It's going to be decreasing. So this will be -infinity to -1. Okay. And here's the answers here. I think we got this all right. Yeah. Good deal. All right, now, all right, here's one that's not vertex form. Okay. All right, so let me bring this paper back over here. We've got the function of x equals x squared minus 2x plus 5. Okay, now the axis of symmetry. X equals -b over 2a. This is the axis of symmetry. And that's what we have to do here on this. All right, so x equals -b over 2a. All right, here's my b right there, -2. And there's my a right there, 1. So this gives me 2 negatives makes a positive 2. And then down here, 2 times 1 is 2. And that simplifies to 1. This is the axis of symmetry right there, x equals 1. Which means my vertex, the x is 1. This is my vertex. Now, how do I figure out this number? Well, I just plug 1 in. I just do f of 1. So when I put 1 in there, I'm going to have 1 squared minus 2 times 1 plus 5. Which is going to be 1, -1, 4. All right, so this is 4. And there's my vertex, 1, 4. Okay, so the vertex is 1, 4. Okay, now if I graph this, 1, 4 is right here. And then looking from x squared, there's no negative, so it's concave up. And there's no number, which means when I go over 1, 1 squared would be 1, it goes up 1. When I go back 1, -1 squared is 1. And again, if it had like a 3 in front of here, 1 squared would be 1. I would go up 1, but since that's a 3, I would times it by 3. It means I'd have to go up 3. Anyway, this is my graph right there. I didn't do a very good job drawing it. But. Now, the axis of symmetry right there. The domain, every time, -infinity, +infinity. The range, all right, this thing goes from 4 all the way to infinity. The 4 we included. Okay. And then we got the domain is increasing or decreasing. Increasing, this is increasing right here. So it starts at 1 right there. 1 to infinity. It starts right here at 1 and it goes to infinity this way. That's, oops, sorry. Starts right here at 1 and it goes all the way to infinity. It's going to be increasing. This part's decreasing, which starts in -infinity and goes all the way up to that 1. So that's when it's decreasing. Okay. And I don't see my answers for, yeah, here they are. It's up here. Here's my vertex. And then here's these right there. So I think we're good. All right, number 5. Okay. All right. A is less than 0, which means A is negative. All right, so if A is negative, that means it's going to be concave down. So it's going to be like this or this. It can't be this one, and it can't be this one. Okay, so since my A is less than 0, that means A is negative. So this is negative, which means it's concave down. Now right here, this is the discriminant. It's greater than 0. All right, if it's greater than 0, that means it's positive, which means you have 2 solutions, which would be like right here. 1, 2, it's got to be this one. It's not that one because that doesn't have any solutions. So the answer is this one, C, D. All right, number 6. Same thing here. There's a few of these on there. I think there's just maybe one on the test. I'm not sure. But here, A is greater than 0, which means A is positive, which means it's concave up. See, my A right there is positive, so this is positive. It's concave up, so it's not this one, not this one. It's got to be one of these two. Okay. Now, if you look at the discriminant, this equals 0. Now, if you remember the discriminant, if equals 0, that means you have one solution, which is right there, one solution. There's my answer, C. And there you can see it was C. What about this one? Same thing again. A is less than 0, which means A is negative, which means this is a negative right here, which means it's concave down. So it's got to be this one or this one. Can't be either one of those two. Okay. Now, if you look at the discriminant, the discriminant is less than 0. All right, if it's less than 0, that means it's negative, which means when I do the square root of a negative, that's going to be imaginary, which means you have no solutions, which means it's going to be, see, this one has 2. It's not that. This one has none. Answer's A. Okay. Number 8. Find a quadratic function whose graph matches this one over here. Okay. All right, well, hey, first thing, see my vertex right there? I know it's going to be x plus 3, because of this negative 3 right here, squared, and it's going to be plus 3 over here. Okay, so it's going to be f of x equals this. Now, I don't know if there's a multiplier here in front or not. Okay, so we got to figure out if it's got a multiplier. So, what I'm going to do, I'm going to put this other point, see, I'm going to put that in for x and y. See, f of x is y. So, negative 6, 0, I'm going to put negative 6 right here. So, let me do that. Negative 6 right there. I'm going to put 0 over here. Okay? Which means I have this. 0 equals a, let me go ahead and minus 3. Minus 3 on both sides, so I've got negative 3 here. Okay? So I've got a times, all right, so I've got negative 6 plus 3, which is negative 3, squared would be 9. And then I divide both sides by 9. And I got a equals negative 1/3. See, negative 3 over 9 is negative 1/3. So this is negative 1/3. This is x plus 3, and this is plus 3. And so there you see my answers right there. Okay. All right, right here, number 9, we're going to divide by synthetic division. So first, 5, 4, 3, 2, 1, 0. We're not skipping any terms. All right, so I'm going to write this out. Now, see, I got x plus 4, which is my factor. So here I got to put my 0, which is negative 4. And then I got a 1x5, and then I got a 5x4, 4x3, 2x2, 5x, and then a negative 10. Okay, and then we'll just bring this first one down here. Negative 4 times 1 is negative 4, and then these two I add. Negative 4 times 1 is negative 4, these two I add. Negative 4 times 0 is 0, these two I add. Negative 4 times 2 is negative 8, these two I add. Negative 4 times negative 3 is 12, these two I add. Okay, which means this is 1 degree less, so this is going to be x to the 4th plus x to the 3rd. There's no x squared. This would be plus 2x minus 3, and then I've got this remainder right here. So that means I'm going to have plus, and I'm going to put 2 over the divisor, x plus 4. And there you go, man. See it right there. That's exactly right. Okay. On number 10 here, we're going to do some synthetic division there. All right, now look here. See, this time we were skipping a bunch of terms. So I got a 1x5, there's no x4, no x3, no x2, no x term, then we got a 32. And then right here's my factor, which means I'm going to put over here a negative 2 in the box. So 1 comes down, negative 2 times 1 is negative 2. Add these, negative 2. Negative 2 times negative 2 is positive 4. Add these, I get 4. Negative 2 times 4 is negative 8. Add these, I get negative 8. Negative 2 times negative 8 is positive 16. Add these, I get 16. Negative 2 times 16 is negative 32. Add these, and I got a 0. So there's my remainder this time, 0. So don't have that. All right, so this will be 1 degree less. This was x to the 5. So this is going to be 1x3, negative 2x squared, plus 4x. Hold on. This was 5. Why did I put 3? It should be 1 less, 4. This would be 3. This would be 2. Negative 8x, and then plus 16. Okay, I don't know why I put a 3 there instead of 4, but there's my answer right there. Okay, just remember this right here is going to be 1 degree less than that, so this would be x4. I don't know why I put 3 up. Actually, I looked up here at this accidentally. Okay, what about down here? Express this in terms, all right, we're going to have a factor here and then a remainder. 2 factors multiplied with a remainder. So here's my k. All right, 4, 3, 2. All right, I'm skipping the x term. So we got 4, 5, negative 13, a 0, and then a 21. I'm going to put a negative 1 there because, see, that's my 0 there because it's k equals that. All right, so 4, 5, negative 13, 0x, and then 21. All right. 4 comes down. Negative 1 times 4 is negative 4. Add these, 1. Negative 1 times 1 is negative 1. Add these, negative 14. Negative 1 times negative 14 is 14. Add these, 14. Negative 1 times 14 is negative 14. Add these, 7. This is my remainder. All right, so what I have here is, this is 1 degree less, so this was x4, so this is going to be x3, so it's 4x3 plus 1x squared minus 14x plus 14. All right, that's going to be in parentheses. This right here I bring down as a factor, which is going to be x plus 1. Okay, it's got to be the opposite for my factor, and then I got this remainder of 7, so this would be plus 7. Okay, and there you go, man. Beautiful. All right, 12. Use the remainder theorem, synthetic division, to find the value of k. So what's f of negative 6? Okay, now you can just put negative 6 in for x. Negative 6 to the 3rd power, negative 6 squared, negative 6, type all that in the calculator, and you get the value. That's the way you can double check yourself. I'll do that here in a minute. But what I'm going to do is 3, 2, 1, 0, not skipping any. I've got negative 2, negative 17, negative 30, and 8. And then here I'm going to put negative 6. All right, negative 2 comes down. Negative 6 times 2 is 12. Add these, negative 5. Negative 6 times negative 5 is 30. Add these right here, I get 0. Negative 6 times 0 is 0. Add these right here, I get 8. And that's my remainder, which means that's the function value. You can see that's right. There's my answer there. But now what I could have done, what I could have done, I could have punched it all in the calculator. Negative 2 times, what was it, negative 6 to the 3rd power plus 13 times negative 6 squared. Well, crap fire. Let me start over. I didn't realize it was still in the exponent. Plus 13 times negative 6 squared, and then minus 23 times negative 6, and then plus 8. And I made a mistake. Ain't that something? Oh, I put a negative 3 in there instead of negative 6. That's what I did right there. I put the exponent numbers, what I put in there. Well, I'm still wrong. Well, I'm doing the wrong dang problem. Forget all that mess. I'm just going to move on. Okay, anyway, the answer is 8. You can just type them in there, but you got to type in the right equation. I was typing in this one here for some stupid reason. We're going to factor this into linear factors given that -8 is a 0. All right, so that means I've got 3, 2, 1. I'm not skipping any, so I got a 2, 13, -23, and an 8. All right, I'm going to put -8 in here, and that should work this thing out. 2, -8 times 2 is -16. Add these, -3. -8 times -3 is 24. Add these is 1. -8 times 1 is -8. Add these, and there you go. I get a 0 like I'm supposed to. Because it says there's zeros. Or it says -8 is a 0. So that means I got 2x squared minus 3x plus 1. Okay, I need to try to factor that. All right, so what I can do, okay, I'm going to do quadratic formula. X equals -b plus or minus a square root b squared minus 4ac all over 2a. Okay, now I'm going to put, I had a nice pen here. There it is. There's my a right there, 2. That goes here and here. There's my b, -3. Goes here and here. And there's my c, 1. Okay, well, my goodness, it ain't on the screen. I'm sorry. So I'll put those in the quadratic formula. There they are. All right, so it means x equals, that's a positive 3. 2 times 2 is 4 down here. And then in this radical, I'm going to write it over here. That's going to be 9 minus 8, which is 1. The square root of 1 is 1. Okay. So I got 3 plus 1, which is 4. Divided by 4 is 1. X equals 1 is one solution. And then 3 minus 1 is -2. -2 over 4 is -1/2. Okay. All right, so we already knew -8 was. So there's my 3 zeros. All right, it wants me to put this in factors. So right here, my factor for this is x minus 1. Right here, my factor for this is going to be x plus 1/2, but we don't usually have fractions in my factors. It's x plus 1/2. So I just multiply both of these by 2, or just slide the 2 over actually. 2x plus 1. And then right there, this is going to be x plus 8. And those are my factors. And there you go. You see them right there. X minus 1, 2x minus 1, x plus 8. We're in good shape. Okay. This one says factor this one. -2 is 0, but it's multiplicity 2. Okay, so let's get on that. All right, so we're going to have to 4, 3, 2, 1. I'm not skipping any terms. So we got a 1, we got 3, we got -20, -84, -80, and we're going to do a -2 right here. Okay, and this is multiplicity 2, so it should do it twice. 1 comes down, -2 times 1 is -2, add these 1. -2 times 1 is -2, add these, -22. -2 times -22 is 44, add these, -40. -2 times -40 is 80, and add these is 0, so there you go. So no remainder there, so now I'm going to go ahead and do it again, since it's multiplicity 2. So 1 comes down, -2 times 1 is -2, add these, -1. -1 times -2 is 2, add these is -20. -2 times -20 is 40, and I add these, I get a 0, which means I have x squared minus x minus 20. I need to find the zeros for that, so I'll just do the quadratic formula. Okay, so x equals -b plus or minus a square root b squared minus 4ac. It's all over 2a. Some of you guys can factor this, which I think in factoring probably be quicker. X, and the two numbers that multiply up to 20, and they subtract and get 1, be 4 and 5. This goes to the big one, it's plus, so there's those two factors right there. So I didn't really have to do the quadratic form, I could have just factored that. But anyway, and then I had this already, so this was 0, -2. -2 is 0 twice, so that's going to make x plus 2, and it's squared because there's 2 of them. So that should be it right there. Look at there. We got it, man. We got it. Okay, let's look at this one here. List all possible rational zeros for this right here. All right, so now when you're doing this right here, it's got to be a factor of 21 over a factor of 1. Well, 1 is just 1 times 1, plus or minus. 21 is 1 times 21, plus or minus. 2 doesn't go. 3 times 7, and that's it. So it's going to be one of these over that, so it's going to be plus or minus 1, plus or minus 3, plus or minus 7, plus or minus 21. These are the possible rational zeros. Possible, meaning that those are the ones that you would want to try if you're trying to break this down. Anyway, the answer looks like it's right here. All right, choose the rational zeros for this. Okay, now we know since this is to the 3rd power, there's 3 of them. So it can't be this one or this one. So it's got to be one of these. So basically what I would do is I would just take 1 here and divide it, see if it divides. So I got 1, 3, -25, 21. And we'll put a 1 here, see if it divides it. 1 comes down, 1 times 1 is 1, add those 4, 1 times 4 is 4, add these, -21, 1 times -21 is -21, yes. So this is right. Now if I did that and didn't work out, then that tells me that this would be the answer over here. It had to be that one. So now if this is my zeros, which one's my factors? Well, since that's a 1, I should have x minus 1, could be this one, or this one, not this. Oh no, there's x minus 1 there. But I got a 3, I got an x minus 3, and an x plus 7. The answer is A. Okay. All right, 16. All right, find a polynomial p of the lowest possible degree having real coefficients with these zeros right here. Okay, that's not that hard of a task. This piece of paper here we use. I'm running out of paper. Okay. All right, so we know this is 0, which means x minus 2 minus 3i is the factor for that. And since this is a 0, 2 minus 3i is also a 0. Since that one is, this one is, which means x minus 2 plus 3i would be another factor. Then -2 is a 0, which means x plus 2 is a factor. And then 1 is 0, which means x minus 1 is a factor. And just multiply all them together. Okay, so I think the best thing to do is multiply these two together and multiply those two together. So I'm going to build my little box here like we've done before. I'm going to put x minus 2 minus 3i here. Okay, when you do this, these two squares will always cancel those two squares, so I don't have to worry about them. This is x squared, -2x, -2x, 4, and then right here in this one, we got 3i times -3i, which is -9i squared, and of course I squared is -1, which is a 10. Okay. So that gives me x squared minus 4x, and then plus 14. So there's what I get when I multiply these two together. I get that. Now I got to multiply these two together. And I just do FOIL for this. X squared minus x plus 2x minus 1. Or minus 2, I'm sorry. Which is going to be x squared plus x minus 2. Okay? X squared, it's going to be plus 1x minus 2. And now I just multiply those two together. All right, so I'm just going to build me a box underneath this one. I'll put this guy to the side here. Okay, now right here I got x to the fourth, negative 4x to the third, 14x squared. This is going to be x to the third, negative 4x squared, 14x, negative 2x squared, 8x, negative 28. All right, so final thing here, that's x to the fourth. It looks like negative 4 plus 1 would be negative 3, x to the third. All three of these go together, so 14 plus negative 4 would be 10, would be 8, x squared. 14 plus 8 would be 22x, and then minus 28. That should be my answer right there. All right, let's check it right here. Okay. I'm off, man. What did I do? Ain't that something? I'm off. Right here. What a freaking idiot. Right there, man. Negative 9 times negative 1 is just 9, not 10. What a... I swear, man. Today's not a good day. That should be 9, which makes this a 13 right here. So that's going to throw stuff off. This whole column. 13, 13. This would be 26. What an ignorant son of a gun. I don't know why I did that, man. Oh, gosh. So these two stay the same. This one's going to change 13 plus be 9, be 7. And this is 13 plus 8, which is 21. This be 26, and that's right. I think that's what I had on there. Yep. So, you know, don't do this kind of ignorant stuff. That's what I did there, something ignorant. So, oh man. Maybe we can redeem ourselves with this one. Find all the complex zeros of this polynomial function. Okay. Get a sheet of paper here. The complex zeros of this. Now, let me write it out here. So there it is. We want to find the zeros of that. Now, it's going to be a factor of 192 divided by a factor of 1. Okay. So 1 and 192. 2 would be, was it 96? 3, all right, 3 goes into it 64 times. 4 goes into it. 4 goes into 19 4 times, 32, 48 times. Okay, 5 doesn't go into it. 6 does. We'll go 6 this way. 32 times. 7 doesn't go. 8. Okay, 8 goes into it. 2, 4. And then 9 doesn't go. 10 doesn't go. 11 doesn't go. 12 goes into it. Is it 18? 12, 72, 16. There you go. Now that's kind of, I don't know if that makes sense, but these are all the factors of 192. So it's going to be one of these divided by the factor of 1, which is just 1, but it could be plus or minus. So it's any of these right here. All right, so this may take a few minutes because we're going to have to figure out one of these zeros for this. All right, so it's sort of like a hit and miss thing. All right, so we're going to divide this down. I got 1, 6, negative 4, 72, negative 192. And you know, I like how this goes from positive 72 to negative 192, so I'm going to try like a 3 here. 3 goes into it, so 1, let's see here, 3 times 1 is 3, 9, 3 times 9 is 27, add these, which is 23, 3 times 23, 9, 69, add these, this is going to be 141, it's not going to work. All right, so 3 didn't work. All right, let's try negative 3. Oop, number line too, a little too close. All right, so 1 comes down, negative 3 times 1 is negative 3, add these is 3, negative 3 times 3 is negative 9, add these 13, negative 3 times 13 is negative 39, and add these. So it's going to be 12 minus 9, which is 3, 7, 6, 33. And then negative 3 times 33 is negative 99. That didn't work. Okay. All right, so we've tried 2 there and not very successful. Let's try negative 4. I like how the negative 3 got closer than what the positive 3 did. So I'm going to try. Wait a minute. Made a mistake right here. It was negative 13. So actually this is going to be either further off. Yeah, I made a mistake there. Man, I'm making mistakes today. Negative 13, positive 39, which is going to be 111. Yeah, so this is way off. All right. Let's try 1, 6, negative 4, 72, negative 192. Let's try 4. 1, 4, 10, 40, 36. This, I think, is going way far off. 144, yeah. It's not, yeah. Let's try negative 4 instead. Negative 4, which makes this a 2. Here, let me just write it over. I don't want to confuse you. Okay, 1, negative 4, 2, negative 8, negative 12, 48. No. Okay, let's see here. We did 3 and 4, those didn't work. All right, let's try 2. Let's try 2. Okay. 1, 6, negative 4, 72, negative 192. And we're going to try 2. 1 comes down, 2 times 1 is 2, 8, 2 times 8 is 16, add these 12, 2 times 12 is 24, add these 6, 96, 2 times 96 is 192. Look at here, man, 2 worked. Okay, so 2 is one of them. All right, now we're down to here now. All right, I'm going to try 2 again. 1 times 1 is 2, 1, 2 times 1 is 2, add these 6, 2 times 6 is 12, add these 24, 2 times 24 is 48, didn't work. Okay. 1, 8, 12, 96. Let's try negative 2. 1 comes down, negative 2 times 1 is... Gosh, man, I messed up here. I'm telling you what, today's not a very good day. This should have been a 10. 2 times 10 is 20. Add these is 32. 2 times 32 is 64. It still didn't work out, but I made a mistake there. I don't know what's going on with me today. All right, so we'll do negative 2. 1 comes down. Negative 2 times 1 is negative 2. Add these is 6. Negative 2 times 6 is negative 12. Add these is 0. That ain't gonna work. Okay. All right, so let's try something else. All right, so I've got 1, 8, 12, 96, and I've already did 2, and let's try 6. Try 6. 1 comes down, 6 times 1 is 6, add these 14. 6 times 14 is, what is that, 24, 2, 84. Add these is 96. That's way off. 6 times 96 is going to be way off. Let's try -6 though. Man, this problem's taking too long. 1 comes down, -6 times 1 is -6. Add these 2. -6 times 2 is -12. Add these 0. Man. Let's see here. I did 6 and -6. Okay. Let's try 8. 1, 8, 12, 96. Let's try 8. 1 comes down. 8 times 1 is 8. Add these 16. 8 times 16 is 128. Add these is 140. It's way off. Try -8. 1 comes down. -8 times 1 is -8. Add these 0. -8 times 0 is 0. Add these 12. -8 times 12 is -96. There it is. All right. So I've got x squared plus 12 equals 0. All right. So there's -8. All right. So let's go back here. I've got 2. I've got -8. And then I've got this x squared plus 12 equals 0. All right, so I minus 12 on both sides. And then I do the square root. X is going to equal plus or minus the square root of -12. The negative comes out as an I. And then the 12, 2 times 6, and 2 times 3, that's a pair of 2's coming out, and the 3 is stuck. These two 2's pair up to come out, but this 3 is stuck in the radical. There we are. Okay, I could have cheated and looked at the answer a while ago, but I didn't. So there you go. I got my -8, I got my 2, I got my -2i radical 3, and my +2i radical 3. So I got them all. So we're in good shape. Next time I'm going to cheat. That was a little bit harder of a problem there, actually. Which one of the graphs is this one here? Which one is this graph here? Okay, so what we're going to have to do is we're going to have to find our zeros for this. So I've got x to the third minus 4x squared minus 15x plus 18. It's got to be a factor of 18, which is 1 and 18, 2 and 9, 3 and 6, and that's it. Okay, I should have cheated and looked at it, but I didn't. So 1, -4, -15, 18. I'm going to try 1. 1 comes down, 1 times 1 is 1. Add these -3. -3 be -18. And look at there, we got it, man. So now I can maybe factor this. X squared minus 3x minus 18. Two numbers that multiply to 18. 1 times 18, 2 times 9, 3 times 6. And they subtract and get -3 right there. So 3 and 6, this automatically goes to the 6, and that tells you they're opposite. So there's these factors. Okay. So I've got x equals 1, so it's x minus 1. So there's my factors completely right there. Okay. Which means I have a 0, x equals 1, x equals -3, x equals 6. There's my zeros right there. So I need to look at the graph and see which one has these 3 zeros. So I should have one at 1. Okay. I don't think this one's right here. I think we're right here at 1 and -3 and +6 right there. There's my answer D. Got it. All right. I got these zeros right there, and that's the one that has those 3 zeros. Now, if there was 2 that had the same zeros, I'd look at the position of the highest. See, since this is positive, it tells me the right side's going up, and the left side's going down. Since it's odd. So see, the left side's going down, the right side's going up. I'd have to look at that if it had 2 that had the same zeros, which I don't think it will. All right, now which one's the graph of this? Okay, now I'm going to do that first on this one, because see here, And I probably should have done it on the last problem. It probably would have told me the answer without having to do all that. Because see, since this is negative, that means on the right side it's going down. And since that's an odd power, that tells you the left side's doing the opposite. So it's going to go up on one end on the left and down on the right, which looks like this one could be this one. But see, now how this one's spaced out right here, I think this is doing a little bit more stuff because this only has 3 zeros. This has like 5. So the answer's going to be B. I could have done that on the previous problem, you know. I spent too much time doing that. Okay, here you go. The end behavior here. All right, so since it's negative, the right side's going down. Since it's an odd power, the left side does the opposite, so it's going up. So, looks like D here. Yep. Okay. Now graph this one. Okay, so basically you got to find your zero. So this tells me I got x equals 0 is a 0. Right there, x equals 4 is 0. And right there, x equals -3 is a 0. So you got to plot these on there, and then you have to have a height point. Usually I put 0 in for a height point, but since that is a 0, I got to do a different value. So I'll just put 1 in. So I got to do f of 1. So when I do that, 2 times 1, then 1 minus 4 is -3, and then 1 plus 3 would be 4. And multiply those, so it's going to be 2, -6, -24. So 1, -24, this is my height point that I got to have. And so I just plot these on the computer, starting left to right. So the furthest to the left would be -3, so I'd plot that one. And then I'd have 0, 0. And then the 1, -24, which would be down here. And then the 4. So see, there's these 3 points. And once I draw these 3 points, the computer will generate this thing and then make it do this, you know, like it does here. Anyway, it'll make the graph for you, which it's going to look like this. All right, 22. All right, graph this one. All right, so here's a, look here. This is x equals 0, but see how it's squared? That means it's going to touch and turn. Right here, x equals 3. It's going to pass through at that point. And then x equals -5, and here it touches and turns again because it's even. So here's my 3 zeros. Okay. And so we got 0 right here. See how it touches and turns? And then at, let's see, 2, 4, 5, positive. Well, that's positive 5. It's -5. That ain't it. So see 0 here. It touches and turns. 2, 4, -5 right there. And it touches and turns. And then at 3 here, it passes through. These zeros look good. Okay. But now I'm thinking that there's no one here. See, -5, 0, and 3. It does the same thing there. But see, this one is going up on the left and down on the right, where this is going down on the left and up on the right. So it's got to be one of these two. This is not right. So it's one of these two right here. Okay? Now, how do you know which one it is? Well, if you look at your lead coefficient, which is x squared times x squared here. I multiply these together, and I get x to the 5th power, which is positive, so the right side's going up, and since it's odd, the left side's going down, which is what we have right here, B. That's my answer, B. Okay. Sketch the graph here. All right, so we got x equals 1 is a 0, and it's squared, so that means it's going to touch and turn. And we got x equals -5 is 0, and it's just going to pass through there. All right, so here's my zeros from the factors. All right, so I've got positive 1 here, and it touches and turns. It could be this. And then -5, it passes through. That looks good. This one don't have those two. All right, so here I have, again, positive 1, and it touches and turns. And then -5, it passes through, so it could be this one. And this one, well, -5 does not touch and turn. See, it's supposed to pass through, and it touches and turns if this is not right. So it's one of these two. And again, we just need to check the end behavior. So this is going to be x squared. This is going to be x. This is x to the third. It's positive, so the right side is up, and the left side is the opposite. So it looks like this one. C. And that's what the answer is, right there. Okay. All right, graph this polynomial. All right, so we need to find a 0 here, so let's go 1, 3, -1, -3. All right, I gotta see something here now. See how these are the same two as those, but the opposites. All right, so that tells me right there that I think we're going to just try 3 here. -3, I believe. 1 comes down, -3 times 1 is -3, add these 0. -3 times 0 is 0, add these -1, -3 times -1 is 3, and I get a 0. So this is x squared minus 1. So if I add 1, x squared equals 1, square root it, x is plus or minus 1. Okay. All right, so I do like I did before. I've got, here I'm going to write them out as coordinates. I got 1, 0, I've got -1, 0, and I've got -3, 0. So here's my 3 zeros I just found. I need a height point. All right, so I'm going to do 0 this time. Since 0 is not one of my x's, I'm going to put 0 in, so 0, 0, 0, -3. There's my height point. And so I just plot those on the graph, and it'll graph it for me. But go from left to right. So the furthest to the left would be this one, so I'm going to plot it first. The next one would be this one. The next one would be my height point. And then the next one would be 1, 0. And once I put those points in that order, it'll graph it for me. Okay, you got to make sure. I've seen people that would just barely, like right here, just barely get off the axis a little bit, and it looks like it's on there. You just got to make sure, read over to the side when you do this, read over to the side, it tells you what the coordinates are. Make sure you're on the proper coordinates. Okay. Graph this one. All right, now look here now, we don't have a coefficient term, so I can divide x out of this. Okay, so it tells me 0, x equals 0 is 0. Now this here I need to solve it. We'll just do quadratic form. X equals -b plus or minus the square root b squared minus 4ac all over 2a. All right, my a is 1, my b is 5, my c is -750. So I've got -5 plus or minus. Down here I got 2, and my radical, I'm putting my radical over here. This is going to be 25 plus, oh man, it's getting bigger. Let's push this in. I've got 5 squared minus 4. All right, 3,025, and I think that's a perfect square. Yes, 55. All right, so -5 plus 55 is 50. Divided by 2 is 25. There's a 0. -5 minus 55 is -60. Divided by 2 is -30. And we already knew x equals 0 was 1. So here's my 3 zeros. So I just look at the graph and see which one has those 3 zeros. So if you notice, they all have 0. See there? 0, 0, 0, 0. They all have that one. This one, though, don't have positive 25. This one don't have the -30. All right, so positive 25 looks like it's right there, -30 right there, positive 25, -30. All right, these two are both possibilities. Okay. Now, Look at your lead coefficient here, lead term. It's positive, so the right side's up. And since it's an odd, the left side's down. It has to do the opposite. So it's got to look like this, which is A. And sure enough, man, A's the answer. All right, we're using the intermediate value theorem here. What's f of -5? All right, we've got these two values. We want to see if there's a 0 between -5 and -4. So first we find f of -5. So I could just plug -5 in, but I'm going to do the synthetic division thing. 1, 3, -9, -13, and I'm going to do -5. Okay. So 1 comes down, -5 times 1 is -5, add these, -2. -5 times -2 is 10, add these 1, -5 times 1 is -5, add these, -18. So -18 is my function value of -5. I'll do the same thing for -4. So I got 1, 3, -9, -13, and I'll do -4 in here. 1 comes down, -4 times 1 is -4, add these, -1. -4 times -1 is 4, add these, -5. -4 times 5 would be 20, add these is 7. So I get 7 for this. Okay, and there you go. Since this one's negative and that one's positive, to get from a negative to positive, you have to cross it through 0. So there has to be a 0, at least one, between these two values. So I think we're looking at A right here. Since these are opposites, there exists at least one 0 between them. So the answer is A. Okay. 27, you're chugging on through. Give the equation of the vertical, horizontal, or oblique asymptotes of this. All right, so in the bottom down here, the vertical asymptotes is when the denominator is 0. So let's x equals negative b plus or minus a square root b squared minus 4ac all over 2a. All right, my A in this is 2, my B is -1, and my C is -21. All right, so it means I got 1 plus or minus, down here I got 4, and then my radical here I got 1 plus 8, 168, 169, which is 13. Square root of 169 is 13. So 1 plus 13 is 14, 14 over 4 is 7 over 2. All right, there's 1 0. And then 1 minus 13 is -12. -12 over 4 is -3. All right, so there's my 2 zeros. So these are my vertical asymptotes. So that means I just put 7 over 2, comma, -3. Okay. Which is right, just checked it down here, that's right. Those are my vertical asymptotes. Now the horizontal asymptotes, that's when you check, now remember, I'm gonna go write down a note here real quick. Horizontal asymptotes. Okay, you look at the degree of the numerator versus the degree of the denominator. So if the numerator is greater than the denominator, okay, there is none. Okay, that means you have oblique. Okay, number 2, if the numerator is equal to the denominator, then that means y equals, or you got to divide the lead terms. And number 3, if the denominator is greater than the numerator, that means automatically y equals 0. Okay, so these are the 3 cases that you have for horizontal asymptotes. Okay, so in this one, see the degree on the top's 2, the degree on the bottom's 2, they're the same. So they're equal. So that means you got to divide the lead terms. So I divide the lead term here is 1, that's 2, 1/2. Okay, which is what we got there. All right, the oblique asymptote, well, since we have a horizontal, then there is no oblique. You can't have a horizontal and an oblique. You only have an oblique if you have no horizontal. Okay, there you go. Now here's another one. Okay, so I have x squared plus 5. Now look here, x squared plus 5, there's no way this could be 0. There's no possible way. Anytime you have x squared plus a number, 1 or whatever, there's no way, when it's x squared plus something, there's no way it could be 0. So there's no vertical asymptote on this one. Okay. Now, what about the horizontal one? All right, we look at the degree in the top. So you do the same thing we just wrote down here. Okay, so my degree in the top is 2. The degree in the bottom is 2. They're the same. So again, since they're equal, I'm going to divide the lead terms, which means I'm going to have 7 divided by 1, which is 7. Y equals 7. Okay, and that's right. That's what it says down here. And now oblique. All right, since we have a horizontal, there is no oblique. You can't have a horizontal and an oblique. You only have an oblique if there's no horizontal. See there? The only way you have an oblique is if you have no horizontal asymptote. Okay, 29. All right, so we got this graph here. Identify any vertical, horizontal, or oblique asymptotes in the graph. All right, vertical. Identify any vertical asymptotes. There's one right there, man. It's, what is it, 2? It's x equals 2. Yep, that's what it is. Okay, but the horizontal asymptote looks like it's up here at 5. This is going to be y equals 5. Okay, which is what we have down here. And then, does it ask about oblique? It doesn't, does it? No, this is right here. All right, the equation, it's the A or B here. So we have A, so there's no B. Okay. Then down here, the domain of F. All right, look here. The domain, this asymptote right here splits up my domain. So we have negative infinity this way, all the way up to 2. So it's going to be negative infinity to 2. All right, and it'll have a union. And then right here, I go from 2 to positive infinity. Okay, there you go. We got it down here. So we're in good shape. All right, number 30, we're getting close. Sketch the graph of the rational functions. We're going to sketch it this time. Okay, so first we need to figure out my zeros down here in the bottom. All right, so let's see here. I think this is going to factor x and 2, x and 4. This would be negative and that'd be positive. Okay, so that means x equals negative 2, x equals positive 4. These are my vertical asymptotes. So looking at the graphs, okay, here's, that looks like negative 2, and I think that's right for 4, so they look okay there. Negative 2 and 4, this looks okay. Negative 2 and 4. All right, this is positive 2 right here, so this one's out instead of positive 4. Okay, now we have to plug some values in to see what's doing what where. So like right here at 5, if I put 5 in, is it going to be up here giving me this? Is it going to be way up there giving me that? Or is it going to be down here giving me this? So we're going to do f of 5. So if I put 5 in, 6 times 5 over 5 squared minus 2 times 5 minus 8. Now, in my experience here, do the top first, then do the bottom separately. So this is going to be 25 minus 10, which is 15, minus 8 would be 7. So it's going to be 30 over 7, which is, what is that, 4 point something. Okay, so it's not this, because see, this is negative. At 5 right here, see here, at 5, this is negative down there. See that? So this can't be it. At 5, right here, this looks like that's 5, so that's below 5, which is what that is. This looks like 5, which is above 5. I think it's this one right here, and it is. Now, if you can't tell on those to be sure, you could stick a value over here on this side, but I believe we're good at B here. 31. Graph this one. All right. So, oh, we could have done a horizontal asymptote on that one, and it might have helped us some, but I didn't do that. If I do the horizontal here, the degree in the top is 1, the degree in the bottom is 2, so it's y equals 0 is my horizontals. This looks right, this looks right, this looks right. They all have the same horizontal. All right, in the bottom, x squared minus 9, this is going to be x equals 3, x equals negative 3. So x equals 3 and negative 3, this one looks okay. 3 and negative 3, this looks okay. Okay, I don't think this is right here because this is 2, 4. This looks like 6, negative 6. That's wrong. And this looks like 3, negative 3. So that one's okay. So of these 3 right here, we've got the answer in one of those. Okay. Now, what I'm gonna do is I'm gonna do f of 4. See, 3 is an asymptote here, but at 4, see, is it down here or is it up there? Okay, so we're gonna do that and find out. So we've got negative 6 times 4 over 4 squared minus 9. Okay, this is going to be negative 24 on top, 16 minus 9 will be 7 on the bottom, which is negative 3 something. And it can't be this one because see here, here's my asymptote at 3. At 4 right here, this is positive. That's not it. See at 4 here, this is negative, so it could be this one. We said it could be in this one, so at 1, 2, 4, at 4 it's negative, so it could be that one. So it's down between these two now. Okay, so now what I'm going to do is I'm going to come in here and look in the middle there. See how this one goes from left to right, up to down? This goes down to up. All right, so what I'm going to do is I'm going to put 2 in. See, 2 would be negative. Here, 2 would be positive. So I'm going to do f of 2 at this time. Okay, let me get on the screen a little bit better. So I'm doing f of 2, which is negative 12 over 4 minus 9 is negative 5, which is 2.4, positive. Okay, so that tells me right there at 2, we're positive 2.4 right there. See here at 2, this is negative, it's out. It's got to be B, and of course there's my answer right there, B. Okay. 32, graph this rational function. Okay. All right, we can see here the degree in the top is 2, the degree in the bottom is 1. The top is bigger. So see, it tells me right there, since the top is bigger, there's no horizontal, we got an oblique, which means we're going to have one of these. It's not this one. Okay, we've got an oblique asymptote. Okay, what is that asymptote? It's going to be 1x squared plus 0x plus 1, and this is negative 4. See, my 0 for this is negative 4. And I'm just going to divide this. It's going to be 1. Negative 4 times 1 is negative 4. Add those negative 4. Negative 4 times negative 4 is 16. Add these 17. I don't worry about this. But this is going to be x minus 4. This is the line that the asymptote, the oblique asymptote takes on. So it's going to go down 4. See, this is my y-intercept, down 4 and up 1 over 1. So it could be this one. All right, this is up 4, looks like. See here? See my dotted line there? It's up 4, so it's not that one. And this one, okay, look here. It goes up 4, and it's also going down 1 over 1. See, this is supposed to go up 1 over 1. So I think A, just by looking at my asymptote, tells me it's the right one. Okay, and we got some varying now. X varies directly as y, and x is 10 and y is 2. Find x when y is 4. So x varies directly as y. First you do this, x equals k times y. Then you do this. This is a 3-step problem. You do this, then you put these numbers in. So x is 10 when y is 2. Solve this out. Means k equals 5. So now I'd write this out here. since k is 5, x equals 5y. And now I do this. What if y is 4? X would be 20. And that's my answer, 20. Okay, it's a 3-step process. Right here, here's the first part. Z varies inversely as W. So Z varies inversely as W. So it's going to be like that. Okay, then you have this part here. Z is 6 when W is 5. So Z is 6 when W is 5. Alright, so if I solve this, multiply by 5 on both sides, it looks like 30. Which means now that since k is 30, Z equals 30 divided by W. And then I go to the third part. Find Z when W is 10. 3. There you go. Alright, here, 35. Alright, suppose R varies directly as the square of M and inversely as S. So R varies directly as the square of M and inversely as S. So there you go. There you set it up like that. Okay. Then you go to this next part. If R is this, M is this, and S is that. Alright, so it means R is 12 when M is 9 and S is 9. Alright, so 9 squared, and this 9 would cancel one of them off, so that's just going to make this 12 equals 9k, so divide by 9, and that simplifies 4/3. So there's what k is. Alright, so now since that's 4/3, it means R equals, alright, the 4 will stay on top with the M squared, and the 3 will come down on the bottom with the S. Alright, so there's how my equation looks. Now I can go this last part. This is M is 45 and S is 9. And I'm going to punch it in the calculator because I don't feel like doing it in my head. But now when you punch this in, I'm going to show you this. I'm going to do 4 in parentheses 45 squared, and I'm going to divide by 3, and we'll divide again by 9. Oh crap, I didn't hit my 9 very good. There it goes, wasn't working. 300. And that's what the answer is supposed to be, 300. Okay, 36, 2 questions left. The pressure exerted by a certain liquid at a given point varies directly as the depth of the point beneath the surface of the liquid. All right, so we're looking at the subject here of this sentence is pressure, and it varies directly as the depth. All right, so pressure varies directly as the depth. Okay, and then we go to this part. The pressure is 70 at 2. The pressure at 70 feet, so 70 is my depth. The pressure is 280. So if I divide by 70 on both sides, that gives me 4. So that means now P equals 4D. So what's the pressure at 20 feet? 20 is my D. 80. There you go. 80 was right. And one last one. Okay. The distance that a person can see the horizon on a clear day from a point above the surface on Earth varies directly. All right, so what's my subject? The distance varies directly. Talk to your English teacher about this. That's what you always look at, the subject and the verb here. The distance varies directly as the square root of the height. There you go. That's how it sets up. All right, so then we get to this part. If a person 64 meters above the surface of Earth can see for 12 kilometers to the horizon. So they're 64 meters above the surface, that's their height. They can see 12 kilometers. Which means that's square root of 8, that's 8K. So divide by 8. That's 1.5. There you go, 1.5. So t equals 1.5 times the square root of h. So there's my equation. Now the last part says is, how far can a person see to their horizon from a point 16 meters above the surface? 16 meters above, so my height is 16. So that's going to be 4, it's going to be 6. This is what it is, 6. All right, so that's the test review. Rather lengthy review, but it was in depth and you probably needed it. So if you have any questions, give me a holler. I'm here for you anytime, all right? Have a good rest of the day.